Let's review identifying slope from a graph. This is from 6.5. Okay, so when we graph a linear function, what we actually have is an infinite collection of points. So a line is just an infinite collection of points. So every single x value and its corresponding y value, that's what happens with a linear function. You input x's, you get a corresponding y output. All of these points fall on the same line. So in this graph right here, we have all of our x values, then we have all of our y values, and then we have this function that is graphed. It is a collection of x's and corresponding y's. When we talk about the slope of a graph, we are talking exclusively about the individual graphed function and the steepness of that line. We are talking about the rate at which that line is changing. The larger our slope, the steeper our line, because the larger our slope, the faster our points are changing. So in order to calculate our slope, we need to use a fraction where we are looking at the change in x divided by the change in y. Just a reminder, those little triangles, these are called deltas. Here, I'll draw it. So that's a delta, and that means change. So our change in y values divided by our change in x values. And this will work for any single 2 points on a graph, any 2 points on this graph, because this is a linear situation, so the rate of change is consistent. However, for our purposes, it is easiest if we pick points that are very, very easy to identify exactly because they lie on the grid. So this example graph we have, I can identify 3 very clear points. One of those points that is super easy to identify is this point right here, which is actually our y-intercept. It's where this graph intersects with the y-axis. And that is the point 0, 5, or where x is 0 and y is 5. I see an exact intersection right here at the point where x is 1 and y is 2.5. And I see a point exactly right here. This is our x-intercept, or where this y intersects with the x-axis. And that is at the point where x is 2 and y is 0. So those are the points we're going to want to use to start calculating this slope. We don't need to know the coordinates right now, so I'm going to erase them. I just wanted to help you identify where these points are. And again, I can use any 2 of these to start calculating my change in y and my change in x. For giggles, I'm going to start with the furthest 2 points. So I'm going to start with this point right here and this point right here. And I'm going to look at my change in y and my change in x. I'm going to start with my bottom point, and I'm going to also start with finding my change in y. So from this bottom point, in order to move up to where my top point is, I need to move up 1, up 2, up 3, up 4, up 5. So I gained in elevation from my bottom point to my top point 5. So it's a positive 5 because I was moving in the positive direction. So my numerator is going to be 5. And then let's look at our change in x. So my change in x, I moved to the negative direction 1, and then in the negative direction 2. So I moved negative 2. So my denominator is negative 2, which means that my slope is -5/2. Or we could write that as -2 1/2. Or you could write that as -2.5. All of those are equivalent. That is our slope, our change in y divided by our change in x. Now I can use other points on this graph. I can start at the top and work my way down. There's all kinds of things I can do, and I will still find the same slope. Let me show you an example of that. Let's use 2 points that are closer together. Let's use this middle point, and then let's use our top point, or our y-intercept. And let's calculate, again, the change in y and change in x. And maybe I'm curious about what happens. Yeah, maybe I want to start at the top point this time. I just want to start at the top point. And I'm still going to calculate my change in y first. So I know that I have to move from the top point to this midpoint, down 1, down 2, down 1/2. So instead of 5 divided by -2, I'm going to end up with -2.5 in my numerator. And then to calculate my change in x, I moved to the right, or in the positive direction, 1, plus 1. So my denominator is 1. And once again, we see the exact same slope. Our slope is -2.5. Something else we looked at is that the slope of a line also represents the unit rate, or the rate of change between our y and x values. So let's give this graph a story. Let's say that this graph is the story of hiking down a mountain. Hiking down a mountain. Okay, and that what my x-axis represents is let's say this is a really long hike, so I'm going to call this hours. And my y-axis is going to be elevation. So elevation. Okay, and then I'll say that's in miles maybe. So I'm saying that the slope of a line also represents the unit rate. Let's again just imagine, now that we have this new situation, here is my y-intercept. So my y-intercept is where x is 0 and y is 5. So at the point 0, 5, at my y-intercept, I've hiked 0 hours. And my elevation is 5 miles. I guess elevation isn't distance. Sorry, let's change that. Instead of miles, I guess we can call it... No, let's keep with miles, whatever. That's fine. My elevation is 5 miles. Okay. Now let's find our slope. And let's see where we're going to be in 1 hour of hiking. So at 1, 2.5, there will be in 1 hour of hiking. Let's calculate the slope there. So again, my slope is change in y divided by my change in x. And we already calculated this on that last slide, so we know that my change in y is I went down 1, I went down 2, I went down another half. So I dropped 2.5 miles. And I did all of that in 1 hour plus 1 because my x values changed by 1. And what this tells me is my unit rate is negative 2.5 miles per hour, which means I am hiking, not hike, there we go, downhill at 2.5 miles per 1 hour. Hope this helps understand slope and put it into context.